My name's Ryan. I'm working with Surgeon and Veeder on what we're calling Leap Conductor. So the idea of this, we got our hands on a leap motion, which basically maps your hand over the device into the as inputs of its position X, Y, and Z for each digit. The motivation for this project was we wanted to extend our previous project, which was a sign language classifier, using a webcam. So leap motion gets us much more accurate data. So we started off just doing that, but that was way too simple because of the accurate data. It wasn't really, it was the same project. So, and there was no regression in it, it was only classification. So we decided to extend that idea and maybe control an instrument where one hand does some sort of, changes some sort of parameter and the other one changes the pitch. We quickly found out that the leap motion only takes one hand, so we had to modify all the processing script and change it to 30 inputs and map those and send that to Wekinator. And then after that, the Wekinator maps it to two different outputs, which are one for each hand, and that's getting sent to a software synthesizer where it controls certain parameters. The complicated part of this was that Wekinator sends OSC outputs, and this software synthesizer takes MIDI inputs. So there's a back-end script we wrote to handle the OSC messages, and then it passes it on, and then that gets converted into MIDI into certain channels, and then in the actual synthesizer, those MIDI inputs get mapped to different parameters. So we initially started trying to use two different Wekinators, and one would trigger the output of another, so we could change what parameters we're controlling with one hand and then control that parameter with another. That got really complicated, so we just mapped the different hands to different outputs and then sent those on. There's a lot of going on in the background here to handle those OSC messages, and that was probably the most complicated part of this project. We also decided to use a neural network as the training algorithm, just because we're using hand gestures to control MIDI parameters, and it's not just simple XY points there or something that's simple. There's interactions and different angles, so we thought that's not quite as easily modeled with a linear or polynomial curve. So instead we used the neural network, and that seemed to be working quite well. To extend this further, we could add more parameters and add more training data to make it more accurate. So in the meantime, then I will give a demo of this, and we'll see how it goes. So you're going to see with one hand I can control the pitch and the speed of the notes, like 8th notes, 16th notes, 32nd notes, and then the other hand controls the cutoff and resonance frequencies for that individual note. All right, that's that.